Hi everyone, and welcome to this video on Python's dunder methods. Today we will have a look at what Python's dunder methods are, and we will see how to leverage them inside of our Python classes. Dunder methods actually are something that you have already seen a lot inside of your Python code, most likely. So if you think about how you would write a class, you would have this peculiar init method inside of it, and this is a dunder init method. Dunder comes from the double underscore at the beginning and after the method. So this is what a dunder method actually looks like. And what are they used for? Their use is to make Python work the way we know it and love it. So most of their work is actually done behind the curtains to make our code more Pythonic. And that's why they're also called magic methods. Another name for which they're known is special method. As an example, let's consider now addition in Python. So suppose we have two variables a and b and they are equals to 3 and 4 respectively. Then we can assign to C their sum, a plus b. And we can do this by means of the plus operator. So if we print this in our terminal, as you can see, we get correctly the sum of these two integers. But what actually happens behind the scenes is that Python, whenever sees the plus operator, it is going to call the add_dunder method of the object that is used. So as you can see, it gives 5, the same way the plus would do it. And this goes also for subtraction by means of the sub_dunder method. And you can see we get -1. And the same works for other Python operations, like, for example, the elevation or division and stuff like that. So now that we understood what dunder methods are, let's see how to leverage them inside of our custom code, in particular inside of a class, to see how we can leverage Pythonic syntax in our code. So suppose we want to represent a vector in our code. We can create a class vector. This class will have an init dunder method to declare its attributes. The attributes will be assigned in this way inside of the class. And so now we have our vector class, and we can define a vector of length 1, 2. And let's see our vector, so let's print it. The component x and the component y. Let's run this. As you can see, we have instantiated our vector. Suppose we want to implement some operations on our vector. What we could do is like create a method for addition, which takes the object and then another object, still of type vector. What it does, it returns another vector with the sum of the two vectors components. Sum for x and the sum for epsilon. Okay, so now we can create a second vector v2 of length -2, 4, and the third vector will be the sum of the two. And if we print the third vector, we will see that it's the sum of our two vectors here. What we can do now with the magic of dunder methods is that we can use, instead of this weirdly named method, our dunder method, and leverage Pythonic syntax with the plus operator. And as you can see, we get the same exact result. So if we want to add another operation for our vector, we can add, for example, multiplication of our vector object with a float. And this will return our vector components simply multiplied for the float. Okay, so if we try this in our code, so we do v1 times 2, let's see what we get instead of the terminal. So we get a vector with components which are double the one of the vector v1 over here. What I don't really like so far is this print to understand what our object vector is. So what we can leverage is another dunder method, the rep dunder method. And what it does is it allows us to return a string which represents our vector object. So we can print for our object its x component and its y component as well. And so here, instead of this f string, I can just print v3. And as you can see, we will get a better representation for our vector object. Some other useful dunder method are the bool dunder method. So suppose we have an integer a equal to 3, we can evaluate how it evaluates as a boolean. So let's print this out and see what it gives us. And we see this is true because a is different from 0. If a would be 0, it would be false. And what the built-in function bool actually does is that it's going to call the bool dunder method under the hood on our integer. So as you see, we still get false. And we can implement this dunder method inside of our classes to get the same behavior of integers in this case, for example. And other useful dunder methods are the len dunder method, which is built inside of, for example, which is available for lists. And so if we want to evaluate the length of a list, we would use the len built-in function, which actually is going to call the len dunder method of our list object. So if we print this out, as you can see, they evaluate to the same length of 3 elements. And other useful methods for lists are the one which implement the Pythonic way of accessing lists and writing to lists with the slices. So, for example, we could print L of 0, and this would be equivalent to call the getItem dunder method on the list, as you can see here. And if we would like to assign an element, a new element to in the index 0 of our list this way, we could actually do this by using the setItem dunder method on our list. So if we are going to print the element at the position 0 in our list, you will see we get 4 because we round setItem after this slice assignment. So if we implement our setItem and getItem in our classes, we could also use on our custom objects this slicing notation. And just to mention a few other cool dunder methods you could use inside of your classes: the equal dunder method, the less than dunder method, the greater than dunder method, and many others. I hope you liked this video. See you in the next one.